Yo guys, what's up? Welcome to my channel Coding Shinobi. And let's discuss what is the internal implementation of hash maps in Java. Let's see how hash maps are internally implemented in Java. So guys, this is going to be a long answer or a long discussion. So I'm going to divide this answer into five parts. Data storage. In this part, we'll discuss what data structures are used internally by Java. Second is hashing and indexing, like why there is a need of hashing and how hashing is useful to have all the operation in constant time complexity. Third one is hash collisions. Fourth, we'll discuss retrieval, that is how map.get works. And fifth one is resizing. When your hash map reaches its limit, how resizing occurs. First, let's discuss about data storage. So hash maps internally uses array of buckets. So this every one is a bucket, and all this includes like buckets. Now, when I say buckets, what do I mean by buckets in this? As if you have solved questions related to linked list, tree structures, you must have noticed that we are creating a node when we are trying to create that data structure. Similarly, you can say bucket is form of that. In node, we usually have this in linked list node usually have data and address of next node. Right. So similarly, in bucket, we will be storing information. Key, there will be key, then value. Again, this can be object, this can be out of object, and then see what is the hash of how to calculate the hash of a key, and then uh bucket next. In case of hash collisions, we need the address of the next element, right? Don't worry. You don't need to worry. We will see what are hash collisions. Hashmap internally uses array of buckets, means Hashmap internally use array and linked list in case of hash collisions. Also, you must remember, like after Java 8, they have started using BBSTs in case of hash collisions. Linked list gives you time complexity of big of n in the worst case. BBSTs will give you log n time complexity. They use this is the thing you should just know. There is no need to remember these things. Just having the knowledge that in case of hash collisions, linked list is used or some other data structure is used, that is enough. The second part is hashing. Now, this is the technique that makes hash maps very popular because of the constant time complexity that it gives for storing and retrieval of data. This is the technique which decides the performance of your hash map. Now let's see, to understand hashing, let's consider an example where you want to store data of students and their marks. So I want to create a map of student name and it marks. In Java, if you want to declare a map, how do you do it? Map of string comma integer. This is the variable name, new hash map. And here string will be student name. Student name is it of type string and marks is of type integer. I have deliberately taken the key as string so that you understand how hashing can make your life easy to store even strings in constant time. Suppose we want to insert some values like map.put. This is a method used to insert values in hash map. So I'm taking, for example, ABC. ABC got 90 marks. Map.put. Now we are going to try to insert these values and let's see how this put method is internally implemented. We do map.put of a hash value of this key is calculated first. Map.put, the hash value of ABC is calculated using the hash code method. Guys, hash code method is of object class, but hashmap has its own implementation to calculate hash code of the key. Now, when we say hash value of a key is calculated, what do we mean? We mean converting the key into a number format. What is the method signature of hash code? It is something like this. Converting this object into its equivalent numerical format is called calculating the hash value of a key. We are just converting, we are just taking key object and then converting, applying some logic here, and then converting into an integer value and then returning that integer value again. So remember, it's very important to write the implementation properly. This is the method that decides the performance of your hash map. Java already has provided the implementation, but in case you need customization, then feel free to override the hashcode method. Now I'm giving you a sample implementation of hashcode. Let's try to implement this. Hashcode method is doing like this is a type object, but I know I will be converting it to the string. I have converted this object, and I'm just I have this variable sum, and I'm just traversing to through this key, maybe whatever the method is there in Java. And then what I'm doing is I'm maintaining a map called as char array. And what this char array will do, mapping, like A is mapped to 1, B is mapped to 2, C is mapped to 3, D is mapped to 4, Z is mapped to 26, right? What I'm doing is simply sum plus is equal to is my char map of just return into 11. This is just a random implementation of hashcode method. This is how I want to implement my hashcode method. Just an example. Well, we're trying to insert ABC in our map. Value of ABC is calculated. How it will be calculated? 1, B is equal to 2, C is equal to 3. What I'm doing is 1 plus 2 plus 3. This is how the sum will be calculated. And then while returning, I'm just multiplying that sum into 11, which is equal to 66. So hash value of turns out to be 66. This is how hashing is done. Java has much more complex implementation, which will make sure you get unique hash values. Actually, Java uses memory reference to convert into a number and then index is calculated. Now, when I say index is calculated, why index is calculated after the hashing? You can just say, na, ki, since the hash values are unique, we will go and store at that particular location. But no, we cannot do that because your hash value can go up to like integer range, like up to 10 raised to 9, maybe. You cannot have your array size cannot exceed this value. Otherwise, it will throw out of memory exception. That's why an index is calculated. Now, index is calculated using this formula. Value that we have gotten, code of p, and we use bitwise AND operator and mask it to this index. And when I say n minus 1, it is the number of elements or buckets in hash map. The default size of our hash map is 16. So your n is 16 in this case, and n minus 1 is equal to 15. 6 hash code of ABC was 66, or n minus 1 is 15. The binary representation of 66 is 100010. Binary representation of 15 is 111. You might be knowing like how AND operator works, right? When both the bits are set, then only the result is 1. Bitwise AND operator is a 0, this is 0. Um, Table for AND looks like when both the bits are set, then only the value is 1. This is how we'll solve it. 1 and 0 is 0. 1 and 1 is 1. 1 and 0 is 0. 1 and 0 is 0. 0, 0, 0, 0. So even if there is 1 0 present, your answer will be 0. This comes out to be 2. 1 0 is a binary representation of 2. When we have calculated the hash code, then we calculated the index, and now add this index, your bucket will be stored. This is your array, and add the index to your bucket will be stored. This is how hashing and indexing is used to store the value in a hash map. You can see the problem with above approaches, right? Like we just did the map output, then we calculated the hash code, and then we calculated the index. It is as simple as that, right? There is a little problem in this, and we will see how what is the problem, how it can be solved. Let's see what are hash collisions. We say hash collisions occur when hash values of two different keys are same. What is the problem in this if the hash values of two different keys are same? It's as simple as that if the hash code is same, if the hash value is same of two different keys, the index will be same, right? So which value is true? Like which value deserves to be in that which value deserves to be stored in that particular index? For example, on this index 2, if there is some other key which has also the same hash value as that of ABC, then will the new key will be replaced with the older one, or like the other value should be discarded? No, that breaks the contract, right? When a user requests you to put the value in your hash map, it must be stored, right? So when hash collisions occur, let's see an example how hash collisions can occur. We have already put this value in our hash map. Let's try to insert BD. What is the hash value of BD? B was equivalent to 2 and D is equivalent to 4. A is equal to 1, B is equal to 2, D is equal to 4, C is equal to 3, right? So 2 plus 4, it comes out to be, sum comes out to be 6, right? And then we were returning sum into 11, which means it is 66. If we refer to this hash code value, here again it is returning 66. Now hash code of ABC is also 66 and hash code of BD is also 66. But a hash collision occurs, what we do is like now this next node comes into the picture. Now we will attach the new key that is colliding with our previous one. And that bucket will be attached to this bucket, to the existing bucket at the index 2. This is how your diagram will look like. At index 2, another node is attached. For example, the address of this one is 1010 maybe, then this will be updated. So guys, I'm not sure how the linked list is updated. Like it is attached to the tail or head. I'm not sure, but I guess the attaching part is big of constant time complexity, so it might be attached to the head itself. Since BD is also the newer value, right? So it makes sense. Let's update it. This is how your linked list will be updated. Guys, one more question to you. When we're trying to insert BD, the same hash code was generated and hence the same index, right? We, as a user, know the hash code of these two different keys were same. But how does Java differentiate between the keys that these two different keys are generated the same hash code, right? In this case, equals method comes into picture. Whenever two hash codes of or two different keys are same, an equals method will determine if whether the keys are same or not. They will compare both the keys and it will determine whether the keys are same or not. Now let's see with a flow chart how what we have learned so far. This user who wants to store some value in hashmap using put method. First, hash code of this key will be calculated. After hash code is calculated, index is calculated. Index is calculated using hash. After index is calculated, if the element is present at the index, what will happen? It will run equals method. If equals method suggests that the both the keys are same, like it returns true, then what it will do? Update the existing value with new one. But if it is false, then what it will do? It will create new bucket and attach to the existing ones. If the value is not present, then what it will do? It will just create a new bucket at that index. So this is how flow of map.put method looks like. Let's do a small try run. I want to insert into my map ABC, 90. The hash code of ABC comes out to be 66. On this 66, the index comes out to be true. At index 2, element is not present, so it will just create a new bucket. 66 and null. I want to put XYZ. Hash code of XYZ comes out to be 825. So the binary representation of 825 is 111001. And minus 1 what's 15? Binary representation of 15 is this. What does this give? Representation of 9. So our index generated calculated is 9 here. Now at index 9, our XYZ will be stored. Now, for example, I want to put map dot put BD from 85. Now, as we have seen, hash code of BD is 66. Index calculated is 2. Element is present at index 2. Yes, equals method will be run. What this equals method will do, it returns as false. Then it will create a new bucket and attach this ABC. And this will be. Now you understand how hashing works and how it gives constant time complexity for such operations for storage of data in hashmap. Well, let's see like how map.get works now. Let's see retrieval part. Let's see how get method of map works. Let's understand this with a flowchart. This is my user who wants to do map.get of ABC, for example. What will happen? Again, hash code is generated of that key. Based on this hash code, index will be calculated. If element is present at that index, equals method will be used, run. If the value is equal, that equals written true. The key that we are trying to get is equal to the key that we stored in that index is equal, then it will just return that bucket, right? Now, if it is false, it returns false. What we'll do is we'll iterate over the linked list. And then again, equals method is run until we get this true, and then bucket will be returned. If element is not present, we'll return null. This is how get method works. Let's do a dry run on the array that we had already created. I want to do map.get ABC. Hash code of ABC is 66 as we have seen. The index calculated is 2 as we have seen. Is element present at that index? Yes. Is BD equal to ABC? No. Then iterate. We have this next node here. Is ABC equals to ABC? Yes. Then this bucket will be returned. ABC will be returned here. User will just know the value of ABC and which user will get to know the value of ABC, which was 90. Now, I want to do map.get of 123, for example. Hash code of 123 comes out to be, I don't know, maybe like it is 123 itself. Let's assume. And the index comes out to be 6. Let's assume. Is this element present at 6? No. Then it will just return null. Similarly, for XYZ, you can do the same. This is how map.get works. The core implementation altogether revolves around the hashing. Hashing is the part which makes hashmap very popular, and almost every operation is done within constant time. Let's look at the resizing part now. What happens if your hashmap reaches its capacity? The default initial capacity of hashmap is 16, right? When your hashmap reaches its capacity, like all the 16 elements are filled, then resizing is done with a certain load factor. And load factor for hash maps in Java is 0.75. That is 75% of the current capacity. Now, when I say resizing, it also involves the expanding of array of buckets, rehashing all the key value pairs and redistributing them into new array. So when you look at this array, and if I wanted to map to like what comes out to be 16 into 75 divided by 100. This comes out to be 12, means 16 plus 12 is equal to 28. A new array of size 28 is created, and all these values are rehashed again and redistributed into the new array. Like for example, BD is 66. 66 representation was 10000010, and your n is 28. N minus 1 comes out to be 27. What is the binary representation of 27? Binary representation of 27 is 11011. So 11011010000. This came out to be 2 again, but not necessarily it will be 2 again. So this index is recalculated and then redistributed into the new array. If you already know or have an idea or size of your data, in advance, then make sure you define the initial capacity of your hash map using the constructor. You can do that. This type string an integer, my key is of type string, is equal to new hash map. And then here in constructor, you give the capacity. So in the beginning only, your capacity or your n is decided. So guys, this was all about internal implementation of hash maps in Java. This is how internally hash maps are implemented. It is a very popular interview question and I hope you ace in your interviews. Let me know in the comment section if I've missed anything or if my pace was very, fast and you weren't able to understand some parts of it. All the best for your interviews and see you in the next video. Bye bye, guys.